Assalamualaikum warahmatullahi wabarakatuh, and very good morning. So in this video, we'll continue our lesson on chapter 3 and 4, the balanced three-phase system, Y and delta connection. Okay, this is the learning outcomes for this lesson. Okay, after completing this chapter, you'll be able to write phasor equation for the voltage and current in the star and delta connected system. You are also expected, okay, so that you can draw the phasor diagram for the voltage and current in the star and delta connected system, and you can analyze the balanced three-phase circuit in both star and delta connected system. Alright, so for this video, okay, I will teach you on the balanced three-phase load connection for star and star delta load connected system. Okay, so here in this figure, okay, you have the Y and Y system. Y and Y system, or you can say as the star and star system. Alright, so balanced star system is a three-phase system with a balanced Y source and balanced Y load. So this is your source, this is your load. Okay, this is we say that as the Y system. Okay, balance means the impedance for your load is same for all three phases. Okay, and then one important thing is that in the balanced YY system, current in the neutral line is 0. So current that goes through this line IN will be equals to 0. Okay, so we have learned in the class, okay, for a star system, okay, V phase, let's say your VAN, V phase is VP, okay, with 0 degree phase displacement. Okay, and then we have your VBN, V phase negative 120 degrees, and we have your VCN, V phase 120 degrees. This one we assume as the ABC sequence. Okay, but okay, for the line voltage, your V phase must times Z3, okay, and your phase displacement is 30 degrees. Line will lead your phase, okay, 30 degrees. Okay, that is the rule for star connection with positive sequence. Alright, and then for the loads, okay, your line currents will be same as the phase currents. Okay, we know that IA that goes through here will be the same as IA to the load. Okay, so your IA will be equals to your VAN, okay, divide by your Z, because VAN here will be same as VAN for the load, and then you divide it with your impedance. Okay, we know that V equals to IZ, so your I equals to V over Z. Then you can get your I line. Okay, so actually your I line here, okay, it will depends on whatever your impedance is. Okay, it will not, you can get 0 if your impedance is only resistance, okay, for the phase displacement, but you cannot get 0 degrees if your impedance have inductance or capacitance. Okay, so let's say you have IA equals to IA with delta degrees. So then your IB, your current in line B will be equals to IA, which is the same magnitude as IA, but then your phase displacement will be delta minus 120 degrees. Because we know that for balanced system, the phase must be all in 120 degrees phase displacement. Alright, so for this one, for IB and IC, you need to add 120 degrees less or more than the delta. Example, we have a balanced YY system. Obtain line currents in the three-phase circuit as in figure. So it asks you to find the IA, IB and IC. So it gives you here the V phase. This one is your V phase for the source, 440 with 0 degrees, and then it gives you the Z, the ZY, the impedance of the load, 6 minus J8. So obtain the line currents. So we know that this is the balanced system because the V phase is same magnitude. V phase is same magnitude. And 120 degrees phase displacement. And then for the load is also balanced because your Z is all equals, for the three phases. So that one is the balanced YY system. So we convert it to the per phase equivalent circuit. So we have the source and we have the impedance. So your IA here equals to IB and IC, same magnitude. Difference is in the phase displacement. So IA will be equals to 440 divided by 6 minus J8. So we got 44 with 53.13 ampere. But for IB, you need to, if you have IA 43.10 degrees for A, so for B you need to either 43.13 minus 120 degrees, and for C 53.13 plus 120 degrees. So for this one, I think we can assume that the sequence is ABC. Assume sequence is ABC. So this is for the phase displacement. Alright, next example. For this circuit, find the line currents, the line voltage, and the load voltage. So it gives you the phase voltage for the source. So sequence is A, B, C as well. And then your impedance is 10 plus J5. So the line currents IA, same like the example just now. You can just divide the V divide by the Z. We have the line currents for A. So for B, you need to minus 120 degrees. For C, plus 120 degrees. This will be the line currents. Then it asks you to find the line voltage. How about the line voltage? The line voltage is VAB or VBC, or VCA. So line voltage, it gives you here 220 for V phase. So V line is V phase. V line is 3 times V phase. This is for the magnitude lah. But for the phase displacement, we know that your V line relates V phase. 30 degrees. So because V phase you have 0 degrees, then your V line must plus 30. Okay, because it leads. Okay, it leads your V phase 30 degrees. So same as this one, you got the same magnitude for V line, but then for the phase you need to plus 120 because the sequence ABC, so you need to minus 120, and then here you need to plus 120. So we have this value. Okay, the load voltage. Okay, we have the line. Okay, ask you to find what is the load voltage here. Okay, what is the V, Z, load voltage lah. Okay, VAN here. Okay, so you have the current I line, and then you times it with your Z. So actually you will get the same values as the source voltage. Okay, next you have exercise 4, balance Y connected load, phase impedance 16 plus J9, connected to a balanced 3-phase source, line voltage 220. Okay, this one is the line voltage, 220 is the V line. So calculate the line current. Okay, you have the answers here. So please try and do it yourself first. I will give you the solutions in the next video. Okay. So same as exercise 5. So we have 4 wire, 3-phase supply, balanced 3-phase load. Okay, and then we have VRN, and VRN we know that will be your V phase, and then ZL, phase sequence is RYB. Okay, find the line current IR, IY, IB, IN. Okay, draw the phasor diagram of current and voltage. Okay, same as exercise 5. Please, okay, try to do it yourself. Okay, I will give you the solutions in the next video. Okay, next we move to balance star and delta system. Okay, so star and delta means that your source is star. Okay, your source is star, your load is delta system. But okay, it is balanced. Means the Z delta is all same for the 3 phases. So this is the connection for the star and delta. We have I line here. Okay, IA, IB, IC. Okay, and then we have I phase. Okay, IAB, ICA, IBC in the load. Okay, for star and delta system, okay, the star and delta system. Okay, for star source, okay, for the source, at the source we have V phase, VAN equals to V phase, okay, with 0 degrees, and VBN 120 degrees, VCN plus 120 degrees. Okay, the line voltage is Z3 times VP. Okay, this is the phase displacement of your line voltage. And then for your load connection, the phase currents, okay, your phase current here, okay, current that goes through this, okay, line AB, your IAB will be equals to VAB. Okay, will be equals to VAB. VAB is same as this one now. Okay, your VAB divided by the Z delta. Okay, let's say we have the values for your phase is also delta. Okay, then your phase currents for IBC must be minus by 120 degrees because 120 phase displacement, and also for the ICA. So for line currents, okay, lines currents actually it is okay, IAB, okay, times your cert3. Okay, we have learned this in class. So for your delta connection, your I line, okay, is cert3 times the I phase, IAB, and then the phase for your line current must be 30 degrees lags your phase current. Okay, that is for delta connected load. Okay, example, we have balanced ABC sequence Y connected source. Okay, source is Y, 110 degrees. This is your V phase connected to a delta balanced load. We have your Z delta here. Calculate phase and line currents. Okay. Okay, so we can see here. Okay, we know the Z delta is 8 plus J4. Actually, you can convert it to this phasor form, or you can just leave it in the rectangular form. Okay, so for your V phase, VAN will be equals to the V phase for this one equals to V line to line for the source. So V line to line of the source is cert3 times your V phase, okay, with 30 degrees leading. So in the question it gives you your V phase is 100 with 10 degrees. Then your V line to line will be cert3 times 100. Okay, phase is 10 plus 30. So we have your VAB. Okay, then we can calculate your IAB. So we have your VAB, which you have calculated earlier, divide by your Z delta. So this will be your line phase currents. Okay, phase currents in AB. Okay, in phase AB, this one. Okay, with 13.40 degrees. So for your IBC, okay, same magnitude, but the phase displacement is 100 minus 120 degrees. This one is plus 120 degrees from A. Okay, from AB. Okay, so you have this answers. Okay, then the line currents. Okay, the line currents is cert3 times your phase because it's line. So your phase must times cert3. Okay, and then the phase is lags 30 degrees. Okay, lags 30 degrees. Okay, from your phase degrees. Okay, so we have these answers. Okay, so that's all. Thank you very much.